Hi there, welcome to our next video in this integrated Math 1 video series. Today we're going to talk about solving linear equations. But before we get into that, let's go ahead and start with our 5 warm-up problems for today. Alright, so in number 1, we've talked about this before. When multiplying an integer times a fraction, we can actually divide by 21 first and use that to simplify with the 7. So 7 divided by 21 is 1/3, right? 7 goes into 7 one time, 7 goes into 21 3 times. So this is equivalent to 5/3, right? 7 goes into 7 once, 21 3 times, so these are 5/3. So you do not have to multiply by 5 first and then divide by 21. You can divide by 21 first. Number 2, what is 67% of 20? Again, we're going to multiply the two numbers involved without trailing zeros. So really it comes down to 67 times 2. So 60 times 2 would be 120. 7 times 2 would be 14. Add those together and you get 134. So 134. But does that make sense? Of course not, right? 67% of 20 should be a little bit over half of 20. So it should be above 10. So all we need to do is move the decimal until we get something like that. So we move the decimal one place, we get 13.4, which makes a whole lot more sense than 134. All right, number 3, draw a graph that does not represent a function. So there's so many different options here. Let me just draw one that could be an example. So anything in which it kind of comes back on itself. So the exact definition is anything that for every input has multiple outputs. So because to make a function, every input must have exactly one output. But for this input here, we've got actually 3 outputs. So maybe x equals maybe 1 right here. But we have 1, 2, 3 y values that are associated with that. And so it's not a function. So hopefully you drew one that is not a function. Number 4, an auto mechanic charges $23 for a house call plus $14 per hour for any work done. Write a function for the amount of the mechanic charges based on how many hours he works. Use f of x in your notation. So we're going to say f of x equals, and we've worked with things like this before, right? Where we have like this constant or flat fee. And then we have like the per hour or per day, that we've talked about being the slope, right? So in this case, we have 14 per hour and 23 for a house call. So you need to discern which one's which. 23 for a house call. That's a one-time thing, right? It's not going to continue to do 23 every time we increase the number of hours. So 23 is our flat fee, or constant, or initial value. It's what is going to end up being the y-intercept in the graph. 14 per hour, so it's going to be 14 times x. So for every increase of 1 in the hours, we're going to go up 14 in the cost. All right, so that's the slope that we've talked about, and so that's our function there. Using the function from number 4, find f of 5. So we want to find f of 5. F of 5. So anywhere there was an x, we're going to put 5. Okay, so f of 5 is replace all the x's with 5. So 14 times 5 plus 23. So 14 times 5, let's see, 10 times 5 is 50. 4 times 5 is 20. Add those together, you get 70 plus 23 equals 93. So let's, it says describe what it means in the real world context. So that means if this auto mechanic works for 5 hours, he'll make $93. Right? So this 5 represents the number of hours that he's worked, and then the output, our answer here, is the cost of him working for 5 hours. All right? So that's kind of the idea there. All right, let's go ahead and move into our goal for today, which is to create and solve linear equations with and without a real world context. So not only are we solving linear equations, but we want to start by creating it, given a real-world context such as number 4 in the warm-up. But before we do that, let's talk a little bit about how to solve a linear equation. You probably looked at this back in 8th grade, but let's talk about this in a little bit more detail. So there's a lot of ways to represent this. I've seen people use like a scale and a balance scale, and you got to maintain the balance, right? You could also look at it with what's called algebra tiles. So these rectangles represent x. So the length here is 1, and then this distance here is x. So this is an area of x. And then all these little small ones represent a unit. So one, each one of these represents a 1, and then the red ones are a -1. All right, so let's see what we have started here. Our original equation is x plus 3 equals +5. So x, which is just there, plus 3, so we have 3 1s, equals, so there's this line separating it, a +5, so we have 5 1s. So what we're going to do is we're going to solve this. And the idea is that we want to find out what is the quantity of x. So if we can isolate x, if we can get it by itself, we can find out what it's equivalent to on the other side. So what we can do here is we can add on 3 -3s, right? Because we want these positive or positive 1s. We want these positive 1s to go away, right? So we can isolate the x there. So we can actually tack on 3 -1s as long as we do the same thing to both sides. All right, we want to maintain that balance as I talked about a minute ago. So if we tack on 3 -1s here and 3 there, what's going to happen is these are what we call additive inverses. They add to give us 0. All right, 1 and -1, 1 and -1, and 1 and -1. So 3 and -3 add to give us 0. So what happens is we're left with just x on this left side. But if we take the 5 over here and subtract 3, then we're only left with 2. And because this is an equation, we're saying that the left side is equal to the right side. Now we know that x, we know that quantity now is the same thing as 2. So x is 2, which makes sense because 2 plus 3 equals 5. All right, let me show you a little bit more challenging situation here with multiple x's. So we've got our initial equation here is -2 plus 3x equals 4 plus x. So I've represented those below. So we have 3x minus 2. So the order doesn't matter there. But so 3x minus 2, because we're just adding them together. And then 4 plus x. All right, so we want to see how we can isolate x. All right, so what we want to do is get the x's on one side, and then we can isolate one of those x's. All right, so the first thing we're going to do is we can tack on a -x on both sides. Okay, so what's going to happen here, move this little one over. What's going to happen here is positive x and negative x, again, those are additive inverses. So what's going to happen is if I click this button here, these two go away now, right? Because those are 0. Those add to give us 0. And then over here, the same thing is going to happen. Okay, so if all we've done so far is we subtracted x from both sides. So subtract x from this side, subtract x from this side, and now we're left with 2x minus 2 equals 4. Okay? But again, we want to start to get x by itself. So what we want to do is we want to get rid of this -2 here. So what we're going to do is we're going to add to this side. And we're going to do the same thing over here. So we're going to add 2 over here as well. Okay? Let's see. These are additive inverses. And these are additive inverses. So we're just left with the 2x over here. And then we can't simplify anything over here. So it's just, what we're left with now is 2x equals 6. 2x equals 6. And then what we can do from there is we can divide both sides by 2. So we have 2x equals 6. So if we divide by 2, so basically we're gonna cut this in half, basically. Whatever we're left with, we're gonna cut in half. So if we cut this in half, we're just left with this one here. If we cut this one in half, we're just left with this part here. So we're left with x equals 3. X equals 3. All right, so let's check it. If x is 3, so it's going to be negative 2 plus 3 times 3 equals 4 plus 3. Let's check, let's see. Negative 2 plus 9 is 7. 4 plus 3 is 7, so that checks out, right? So what we're saying is if x were 3, then these would be equal. These two sides are equal. If x is any other number, then this is not equal, right? So we're trying to find the value that makes both sides equal the same quantity. So that's kind of how to use algebra tiles to do that. And we're going to continue to think about this idea, but we're going to maybe move into more of an algebra-based representation. So let's go back to our warm-up. It said the mechanic charges $23 for house call, 14 per hour. Write a function, which we already have done. So f of x equals 14x plus 23 was the function that we wrote. If this auto mechanic charges a total of $121, how many hours did he work? So now we're going backwards. We're not saying how much does he charge given the number of hours. Now we're saying he made this much. How many hours did he work? So this f of x part right here represents the total charge, and then x here represents hours worked. Okay, so 121 is the total amount that he's charging. So that's this f of x piece here on the left side. So 121 equals 14x plus 23. All right, so what we want to do is we want to get x by itself, right? We want to isolate x so that we know what quantity it's equal to. So we can subtract 23 on both sides. So subtract 23 on both sides. So 23 minus 23 is 0, so it's going to just leave us with 14x. And then 121 minus 23 would be 98. All right, and then let's see. We have 14 x's over here, right? And so we want to divide both sides into 14 pieces, and just take one of those pieces. So we're going to divide this side by 14, and we divide this side by 14, so that we know what one of x is equal to. Not 14 of them, we want to know what one value of x is equal to. So we're going to get x over here. So 14 divided by 14 is just 1, right? And then 19 divided by 14, let's see, I think we did this a minute ago, didn't we? Let's see, 14 times 5 was 70. So 14 times 6 is 84. 14 times 7, which should be 98. So it should be 7 here. Let's see, 14 times 7 would be 98, plus 23 gives us 121. So that works out, right? So you can always check your answer by substituting it back into the original and seeing if the two sides are equivalent at that point. All right, so kind of same strategy here, but writing it out using more of an algebra representation rather than those algebra tiles. But you can always revert back to those algebra tiles if you want to understand a little bit better, the situation involved. All right, eventually, maybe not right now, but eventually, you should get to the point where you don't need to write this step right here, where you're subtracting 23 or dividing by 14. When you're subtracting 23, you can just go ahead and do the subtraction. You don't necessarily have to write out that step. But wait, and whenever you feel comfortable doing that, go ahead and move on to that. But for right now, you can go ahead and write your work in terms of what you're doing each step. Okay, so let's go ahead and move on to the next one here. We're gonna look at a lot of different examples today and just kind of get familiar with this. So Chad buys a car by paying an initial amount of $5,000, then $250 each month. After how many months will he have paid $8,350? So let's see, an initial amount, that's a key word there, an initial amount of $5,000. So that's not going to increase each month, right? It's just a solid 5,000. It's going to stay 5,000 forever. So that's the constant or initial amount plus 250 per month. And we want to know when. So this is the amount he's paid, right? When is that amount equal to 8,350? All right. So from here, we're going to, again, X is the number of months that have surpassed. We're going to solve for X, right? Because that's what we're looking for, right? How many months will he have paid that amount? So we're going to try and get X by itself here. So the first thing we're going to do is subtract 5,000 from both sides. And when we do that, we're going to get 3,350. Okay, and from there we can divide 250. So we have 250 x's over here, and we want to find out what one of them is worth. So if we divide both sides by 250, we can find out what one of them is worth. So let's see, 3,350 divided by 250. Let's see here. That's going to be, 250 goes into 500. Okay, so we're going to get a decimal here. Let's take out a trusty calculator here. So 3,350 divided by 250, 13.4. Okay, so 13.4 equals X. Okay, so after how many months? So he doesn't pay like in the middle of the month. He pays after each one goes by. So on month 13, he hasn't paid that much yet. It's not until month 14 that he'll actually go above the 8,350. So really, our answer here would be month 14, in which that will happen. So you got to think about use your number sense, use your reasoning skills to think this through. It's like, if this we're looking for like the number of buses it would take to take 250 kids to school, and the answer came out to be 13.4. Well, you can't have 13.4 buses, right? It would be 14 buses. Same thing here. He doesn't pay in the middle of each month. He pays one time every month. And so it wouldn't be till the 14th month that he overlaps or surpasses that 8,350 mark. So hopefully that makes sense there. And you can always check it, substitute 14 in here, and see what that gives you. It'll give you something above 8,350. All right, 10-pin bowling charges a flat fee to rent shoes and a cost per game. Before 5 p.m., shoe rentals cost $2.75 and each game costs $6. After 5 p.m., shoe rentals cost $8.75 and each game costs $4. After how many games of bowling will the total costs be equivalent? Okay, so let's first create the equation and then we can try and solve it. So let's think about before 5 p.m. That could be our left side of our equation. And then after 5 p.m. Okay, so before 5 p.m., $2.75, shoe rental costs $2.75. Does that happen one time or does it reoccur after each game? It only happens one time, right? So that's our flat fee or our constant amount, our initial amount. So $2.75. Plus But then we have this reoccurring amount of $6 per game. So I'm gonna put G here for the number of games. Sometimes it's nice to use the letter that makes most sense to you to represent whatever it represents. So 6G plus 275 after 5 p.m. should cost $8.75. So again, that's just a one-time amount plus $4 for each game. So 4G plus that. Okay, and then wanting to know after how many games. So for what value of G would these be equivalent? Okay, after one game, so you're gonna have 6 plus 275. That'd be 875 here. After one game, it would be 1275. So they're not equal after one game. So how many games does it take? All right, so let's see here. What we can do is, so we got 6G over here and 4G over here. We can subtract 4G from both sides. And that's going to give us 2G over here. And that does not impact the 275. 4G minus 4G is 0G, so nothing there. And then we just have the 875. Okay. From there, we can subtract 275 from both sides. That's going to leave us with just 2G equals, this is because this is 0 here, 875 minus 275 would be 6. So 2G equals 6. So if two sets of G equals 6, what will one set of G be? So you can think about dividing both sides by 2, and G would be 3. So after three games, it would be the same cost, right? So an interesting situation there where we're comparing two things, trying to figure out when they're equivalent. So we've got two variables involved. Again, get the variable by itself. Just remember that anything you do to one side, you've got to do to the other side. All right. So and just to be clear here, let's say we wanted to multiply both sides by 2. Okay. And this is just on a side note here. This has nothing to do with this problem specifically, but I just want to point this out. If you wanted to multiply both sides by 2 from the beginning here, you have to multiply the whole left side and the whole right side by 2. Okay? And so I really want you to think about it that way, because later on, when you get to integrated 2, for example, and you're wanting to take an equation, say x plus 3 equals 6, and you want to square both sides. So, squaring is another thing you can do to both sides. You're not going to just square everything individually. You're going to square the whole left side and the whole right side. So just keep that in mind when doing things like multiplication or squaring things. When you do that to both sides, you have to do it to the whole left side and the whole right side. All right, up next, we got Tim and Rex, and they both received gift cards to get gas for their cars, or at least pay for some of their gas. Tim received a gift card to Petrol USA worth $15, and Rex received a gift card to Quick Go worth $5. The price per gallon at Petrol USA, which is where Tim received a gift card, is $2.21. So I'm going to underline 2.21 and 15 because that both describes Tim, right? Because Tim received $15 to there, but it's $2.21 per gallon. All right, and then Rex is going to Quick Go. He's got the $5 gift card, and it's $1.75 there for gas. So it says, assuming the two pump the same amount of gas, after how many gallons will Rex pay 3 times the amount of Tim? So a little more complicated situation. Let's come up with their expressions first, and then we'll see when Tim's is, or Rex is 3 times the amount of Tim. All right, so let's put Tim over here, and let's put Rex over here. So Rex pays $1.75. So for every additional gallon that they pump, Rex is going to pay $1.75. So that's that reoccurring amount, $1.75 times X, where X represents the number of gallons that they've pumped. Plus, actually it's minus 5, right? Because this is the amount he's going to pay for gas, but minus 5 because he's got that gift card. So he's only going to pay $5 less than that in the end. Whereas Tim is going to pay $2.21 per gallon, but he's got a $15 gift card. Okay? So what we want to know, when will this be 3 times the amount of this? So we are going to multiply this whole right side by 3. Right? So when Tim's value is multiplied by 3, that's going to be equivalent to Rex's value. Okay? When will Rex pay 3 times the amount of Tim? All right, so let's do this algebraically, and then we're going to look at it graphically as well. So let's see. The first thing we can do is distribute 3 into this side over here. So 3 times 2.21 is going to be 6.63x minus 3 times 15 is 45. All right. From there, let's go ahead and try to get x by itself. So we're going to, let's do that on the right side here. So let's try to isolate x over here. Okay, so to do that, we're going to add 45 to both sides. So negative 45 plus 45 is 0, so that's just going to leave with 6.63x over here. And then negative 5 plus 45 is 40. Still have 1.75x. All right, and then we're going to subtract 1.75x's over here. I think I did it to both sides. So it's going to be 0 x's over here, so we're just going to leave us with 40 equals 6.63. We need to pull up the calculator anyways. So 6.63 minus that 1.75 equals 4.88. So we have 4.88 x's. And so we want to divide by 4.88 here to get x by itself. I know it's a little bit harder to conceptualize when we don't have an integer value of x there, but we can still divide by 4.88. It's the inverse operation of multiplication, right? It's 4.88 times x. So to undo that, we're going to do the inverse operation, which is divide. So we're going to divide by 4.88 on both sides. That's going to leave us with x over here. And then I'm going to divide, back to my calculator here. 40 divided by 4.88. That's going to leave us with 8.1967. 8.1967 approximately. And you know, depending on the problem, it may say round to the nearest hundredth or tenth or something. Let me remind you, this is the tenth place right here, right? This is 1/10. This is the hundreds place, thousands, 10,000s, and so on. And so it may say around that there. But after a little over 8 gallons, and we can have a decimal amount of gallons, right? A little bit over 8 gallons is when these two guys will be paying the same amount. Okay? So let's look at it from a graphical perspective as well. All right. So if we zoom out here, okay. So the blue is Tim's times 3. All right, so this is the right side of our equation, which is Tim times 3. And then the red is rex. And we want to know when these values are equivalent. So let's look at rex real quick. So rex had a $5 gift card. So it was like 1.75x minus 5, I believe it is what it was. And so the -5 here, and then the slope is 1.75. So for every increase of 1 in x, we go up 1.75 in the y direction. And so that's going to create this line here. Whereas Tim has his value, which is 2.21x minus 15, but then we're multiplying it by 3. So that's going to create this y-intercept of -45, because after we multiplied the 3 in, we got -45. Anyways, to solve this, we want to know for what value of x is the output or the y value the same. So if we think about this, where they intersect, right there, is going to be that value. So after a little over 8 gallons, they're both going to pay, or sorry, they're both going to output 9.344. All right, so that's actually, this 9.344 only represents the amount that Rex is going to pay. It's actually 3 times the amount Tim is going to pay. But it's at this 8.197, they rounded, gallons that happens. So anytime we're trying to solve an equation, we can always look at the x value in which they intersect. All right, always the x value in which they intersect. And this is going to be a key point. It's going to continue on forever in your math career. Anytime you want to solve an equation, it doesn't matter what the equation is, as long as it has real solutions, you can graph it and see what x values they intersect. All right, so don't forget that. All right, let's go back and move on here to our next one here. So this is kind of a T&E ready type problem to get you to kind of be thinking about what like a multiple choice problem might look like. It says 2 fitness clubs are adding new members. Fitness Club A currently has 450 members and has 15 new members each month. B currently has 400 members and has 25 new members each month. After how many months will A and B have the same number of members? So take a second and see if you can try this one. Okay, so if we look at A versus B, Club A has 450 members. So that's like the starting value or initial amount. And then for each additional month, we had 15 members. So maybe I'll put M for members. So number of months that have gone by. It's actually months, not members. And then over here we have 400 new starting out members, and we have 25 new ones each month. So if we've gone 1 month, then we've only added 25. We've gone 2 months, then we've added 50 members. 3 months, then 75, and so on. So you see that proportional reasoning there. All right, so let's see. If we isolate, and I'll give you a little tip here, to make it a little bit easier in keeping your values positive, you want to maybe isolate the variable with the greater coefficient. So if we subtracted 25 on both sides, we get a -10 over here, which is fine. You can do that. But what I prefer is to keep my variable positive. So I'm going to subtract 15 on both sides, 15m. So that leaves with 0m over here, so it's just 450. 25m minus 15m is 10m. Plus 400. So notice my m is positive now. So eventually when I go to divide, I'm going to divide by a positive number, not a negative number. So it's just a little bit easier, creates less room for error, that kind of thing. All right, so now I'm going to subtract 400. So I'm isolating this m here, so I'm going to get rid of the 400 here. So subtract 400 on both sides. So it's going to be 50 equals 10m. So these are what we call equivalent equations, or equations with the same solutions. So one step leads to another, leads to another, leads to another, And so these are all valid statements given the previous one was true. So now we're going to divide both sides by 10. So 50 divided by 10 is 5. 10m divided by 10 is just m. So after 5 months, these two fitness clubs will have the same number of members. Okay, so we've got 3 more examples, and these are all what we call open middle problems. And so that they've got these blank boxes, and it kind of allows for some creativity on your end. It says, using the digits 1 to 9, at most 2 times each, fill in the boxes to make an equation with no solutions. So meaning when we solve this thing, we don't have any solutions. All right. So take some time. Again, using the digits 1 to 9, at most 2 times each. So you couldn't put like a 4, 4, and a 4, right? Only two times each at most. Using any numbers 1 through 9. You can only put single digits in these boxes. So just try some and see if you can come up with something that creates no solutions at all. All right, so what has to happen here is these two have to match. These two have to match. So for example, we could do 4 and 4. And then it really doesn't matter what these other ones are. I could do like a 1 and a 3. Let me explain why. Going back to our a graphical representation. Remember we said, it's the x value at which the 2 lines intersect, right? Well, if I graph the left side here, and I graph the right side, and I see where they intersect, they're not going to intersect. Why? Well, this has a slope of 4, and this has a slope of 4. So they have the same slope. So what's going to happen is this one's going to be graphed like this, and then this one's going to be graphed like this, and they're parallel because they have the same rate of change, right? They have the same slope, and so they're never going to intersect. And it doesn't really matter what that slope is, but as long as they're the same, they will never intersect. And because they never intersect, there is no solution to that equation. All right, let me show you how this works out algebraically if we were to actually try to solve this. All right, if we were to try to solve this, we would, maybe let's solve for this x here. So we subtract 1 on both sides, and we get 4x equals 4x plus 2, and we subtract 4x on both sides, so maybe minus 4x here, and here. And we get, let's see, 4x minus 4x is 0 equals 4x minus 4x is 0 plus 2 is just 2. And we get 0 equals 2, which is a false statement. So algebraically, if we get a false statement, that's an indication that there's no solution. So something to look out for there, all right? And so you could come up with your own here. There's a lot of different ways to do this one. I just picked 4 and 4 in this case. All right, let's go to another one. Now it says, using the digits 0 to 9, so 0 to 9, at most 1 time each. So you can't use numbers more than once here. Fill in the boxes to write 3 equations whose solutions is negative 1/2. So you come up with 3 equations whose solutions are negative 1/2. So try that. Okay, so there's, again, pretty much an infinite number of ways to do this. Many ways. Here are some examples. So let's solve one. So 2x plus 5 equals 4x plus 6. So let's solve this one and see. So if we subtract 2x on both sides here, we're going to get 5 equals 4x minus 2x is 2x plus the 6. Subtract 6 on both sides, so we're going to get negative 1 equals just 2x there, because these are 0. And then we're going to divide by 2, so negative 1 divided by 2 is negative 1/2. All right, so really what happens here is, as long as the constant that you get, the number that you get on the opposite side is is opposite sign of what's over here and half the amount, then yeah, it should work. All right. So for instance, let's do this one here. So 8x plus 5 equals 4x plus 3. So if we subtract 4x on both sides, again, I want to keep x positive if possible. So I subtracted it over here so that when I do 8x minus 4x, I still get a positive number. So it'll be 4x plus 5 equals 3. So 4x, let's see, we're going to subtract 5 on both sides. So we're going to get 4x equals -2. So again, the number on the opposite side is opposite the sign and half the value. And so we will always end up with, if we divide by 4 here, -2/4 is the same thing as -1/2, right? Because this is 2 times 1, this is 2 times 2, the 2's reduce, leaving us with -1/2. Okay, last one here, using the digits 1 to 9 at most 1 time each. So 1 to 9 at most 1 time each. Fill in the boxes to create an equation such that the solution is as close to 0 as possible. So as close to 0 as possible. So a really, really small positive number or a really, really small negative number. So take a second and try and see if you can come up with that. Okay, so let's see what actually is the closest we can get. All right, so here's our 2 examples. Let's do this bottom one here. So we have 1x plus 7 equals 9x plus 8. So if you notice here, the distance between our coefficients of our x's is as most as we can possibly do, right? The distance between 1 and 9 is 8. And that was we wanted to create the largest gap there. Okay, so if we subtract 1x on both sides, we get 7 equals 8x plus 8. Let's see, subtract 8 on both sides. We get -1 over here equals 8x. Then we're going to divide by 8 on both sides. And that's going to give us -1/8. So positive 1/8 or -1/8 is the closest you can get to 0, given these constraints. All right, and you can solve this one as well. Notice it's going to end up being the same thing because we're going to subtract we subtract 1 on both sides, give us 8x. So we're going to end up dividing by 8 again and getting 1/8. Okay, so final thing here, just want to tack this on here at the end is we've got this equation here. It's got a bunch of variables in it, a's, b's, x's, whatever. And it says if the solution is x equals -1. So again, a solution is a value that makes both sides of the equation equal. So if the solution is -1, which statement is true about a and b? So that means if we put -1 in for x, we should get an equivalent, two equivalent quantities on the left and then on the right. So if we do that, it'd be 2a times -1 plus 3b equals -4. A times -1 minus 9b. And what we need to do here is actually, just simplify things here. So 2a times -1 is just -2a. And then -4a times -1, negative times a negative is a positive 4a. And then we just need to simplify here. Notice all the answers here have a by itself. So let's get a by itself. All right, so let's get this a by itself because we want to keep things positive when we go here. All right, so let's add 9b to both sides. So it's going to give us 12b over here. And then that's going to leave us 4a over here. If we add 2a to both sides, because we wanted to combine the two A's there. So it's going to be 6A equals 12B. 12B. All right, and then what we could do is divide by 6. So if we divide both sides by 6, we're going to get A equals, let's see, 12 divided by 6 is 2. So 2B, A equals 2B. Let's go back up here. A equals 2B, A equals 2B. So it's kind of thinking about, we've got these coefficients that are constants that are represented by letters. And just thinking through like what would happen if -1 was a solution, how would we think through the relationship between A and B? So now that's a little complicated, but hopefully we can think through like if x equals -1 is a solution, I know what that means. I know that means when I put in -1 for x, that my two sides should be equivalent. And so we can use that fact to solve this one. All right. So that concludes this video. Hopefully we reached our goal for today, which was to create and solve linear equations with and without real world coefficients, and then also trying to solve linear equations that have coefficients represented by letters. All right, so hopefully you'll join us for our next couple videos. We're going to apply what we've learned today to not only solve linear inequalities, but also to solve literal equations and rearrange literal equations. All right, so hopefully you'll join us next time.